So in business math, you're going to see a lot of problems involving the quadratic formula, which is the way to solve any quadratic equation. The quadratic formula only occurs when your quadratic is in standard form, and then you could use the formula. But you have to realize that there's a lot of traps and holes of the formula. I'll probably explain the video to the formula again, but what folks have to understand is that you're going to have to practice this, and you're going to have to know some things, and you just have to be careful. Like in this particular problem, this is a situation I see in business math a lot involving a revenue demand function and a cost function, and you're looking for the x where it breaks even. So in other words, you have to solve a quadratic equation. So if you're solving a quadratic equation, what you have to understand is that's not even in the right form. You have to work the equation down to where you are in the right form. I use the distributive property to make x times 12 is 12x and x times negative x is x squared. I still need all the terms on one side. Now, because of the fact that negative x squared is on the left, I find it convenient to add positive x squared to both sides. So next thing I know, I end up with x squared plus 4x plus 11. And then I end up moving, or should I say, adding the negative 12x to both sides. So now I end up with x squared minus 8x plus 11. And then now, because I've zeroed out this side, that's equal to 0. So that's just a little detail on what I actually did to get the equation to be standard form. Now, to continue to go into standard form, I have to also realize that A represents the term in front of x. B represents the coefficient of, A is in front of x squared, B is in front of x, and C is the constant term. And those are the numbers that are going to get plugged into the quadratic formula. So in the next screen, I'm going to go ahead and do the quadratic formula, where A is 1, B is negative 8, C is 11, and it's if ax squared plus bx plus c is 0, then x equals negative b plus or minus b squared minus 4ac over 2a. I kind of scrawled it, I'll admit it. Now, negative b is actually going to be 8, because negative b is the opposite of negative 8. B squared, you have to square a negative and get a positive. If you don't, you're going to get it wrong. And then I have 4, sorry about all the picking, 4 times 1 times 11. Now, I'm going to divide that by 2 times 1, which is just 2. That's going to lead to x equals 8 plus or minus 64 minus 44, which is 20 over 2. And that leads to, in business math, you can simplify the square root of 20, but a lot of people just take their calculator and figure out the square root of 20. And according to my calculator, I know I'm probably doing some irritating things right now. Well, my calculator says 2 square root 5. So the calculator's not doing me any favors either. Oh, the bottom is 2, not 5. Now, here's something else you have to understand, and I got to go to yet another screen for this. So yeah, this process can be pretty arduous. See, it really turns out to be what they call a conjugate pair. This is actually the answers to that equation. Now, you can take the 1/2 out of the expression like that, make it 1/2 of that, and then you could distribute. That's going to lead you with 4 minus the square root of 5. Without loss of generality, you're going to get 4 plus the square root of 5 on the positive side. You can also do things like some people will just cross out 8 2s and 2s, but sometimes I like it better just showing that what you're really doing is you're factoring out half and then you're squaring, or not you're squaring, you're multiplying. Now, in the case of the end, you can approximate this, and it tells me that 4 plus square root of 5 is 6.23. And that's to the nearest hundredth, which often is pretty useful in business. Now, if I do the 4 minus the square root of 5, that's 1.76. So those are actually your two answers to that quadratic equation. Good luck with all your problems. They're not easy. But with the right concentration level and focus, you can definitely do something with quadratic formula.